Okay, after injection, the concentration of a drug in the system depends on absorption and elimination rate. Suppose the function C of t equals 3t times e to the negative t. This models the drug concentration in grams per liter of blood, where t is measured in hours. When does the highest concentration occur? So, if we look at the graph, I've plotted it of 3t times e to the negative t. What we're going to notice is that at time 0, the concentration is 0. Drug concentration gets measured from the blood. So for some injections that are not directly into a vein, into the bloodstream, like insulin that gets injected subcutaneously, at time 0, there is no drug in the blood. It has to be absorbed. Same thing with tablets, anything taken by mouth. So if we look at the graph, we're going to notice that the concentration is going to start increasing, reach a maximum, and then start decreasing. While the concentration is increasing, that's the absorption phase. This is the elimination phase. Notice how it's not a straight line, it changes. So that's why we need our derivatives and we need calculus for this. So we want to take the derivative of this equation with respect to t. From now on, when I say derivative, I mean derivative with respect to t, where t is time. So the first tool is the product rule. So first, 3t times the derivative of e to the negative t, plus second, e to the negative t times the derivative of 3t. So, for the derivative of e to the negative t, if you haven't already memorized it, I'll show you how to figure it out. We're going to use the chain rule. So, if I define a function f of t as 1 over t, or t to the negative 1, and a function g of t as e to the t, I could say that 1 over e to the t is f of g of t. I have g of t, which is e to the t. And now I'm going to plug that into f of t. I get 1 over e to the t. So for a function that could be defined as f of g of t, the derivative of that function is f prime g of t times g prime t. Now f prime t is, we're going to go back to f of t. So negative 1 times t to the negative 1 minus 1, that's negative 2. Derivative of e to the t is e to the t. Now, all I'm doing here is plugging in what I got before. So f prime g of t times g prime t. So that's 1 over g of t squared, because that's f prime g of t times e to the t, that's g prime t. And the rest is just rewriting it, nothing more than exponent laws and all that stuff. So anyway, the derivative of e to the negative t is negative 1 over e to the t. Now, now that I have that, we also the derivative with respect to t, let me get to that in a second, I'm sorry. So now, going back to this equation, so 3t times, so now we got 3t times negative 1 over e to the t plus second 1 over e to the t times the derivative of 3t is 3. That's another way of writing it, and I'm going to show you why I wrote it that way in a minute. We want to set the derivative equal to 0 because at the maximum concentration, time of maximum concentration, the slope of the tangent line is 0. That is why, sorry, it's not so straight, but I think you see where I'm going with this. It's a horizontal line. Next thing we need to do is solve for t. The rest of this is just algebra. We're going to get t equals 1 hour. And that is consistent with the graph. 1 hour is your answer.